Hello everyone. So today is my topic is transmission line. Uh, so transmission line in communication carry telephone signal, computer data in LAN, TV and internet signal in cable TV system, and signal from a transmitter to an antenna or from an antenna to receiver. Transmission lines are also short cable connection equipment or printed circuit board, a coupler track that connect an embedded microcomputer to the other circuit by way of various interface. Transmission lines are crucial link in any communication system. They are more than piece of wire or cable. The electrical characteristics are critical and must be more to the equipment for successful communication to take place. Transmission lines are also circuit, and every high frequency where wavelengths are short, transmission line acts as resonant circuit and even reactive component. At VHF or UHF and micro frequency, most turn circuit and filter are implemented with transmission line. This chapter will cover basic transmission line principle, theory, behavior, and application. So, transmission line is a metallic conductor system that used to transfer electrical energy from one place to another. More specifically, a transmission line is two or more conductors separated by an insulator, such as a pair of wire or system of wire pair. A transmission line can be as short as a few inches, or it can be spanned several thousand miles. Transmission line can be used to propagate DC or low frequency signal. Transmission line behavior is rather simple and quite predictable. However, when propagate high frequency signal, the characteristic of transmission line become more involved. A transmission line is a specialized cable or the other structure designed to carry alternating current of radio frequency signal from one point to another. Transmission lines are crucial in various fields, including telecommunication, radio broadcasting, and power transmission, where they help in the efficient transfer of electrical energy over distance. Okay, we continue with the basic concept of transmission line. So here we have 5 points. One is a transmission line. Transmission line, a medium used to transmit electrical energy from source to load. It typically consists of conductor, dielectric, or we can call insulator, and some shielding. And point number 2 is characteristic impedance. This impedance that transmission line would have if it were infinitely long. It is a critical parameter in matching the line of the source and load prevent reflection. Point number 3, reflection coefficient. A measure of how much wave in reflects to the impedance mismatch. It is defined as a ratio of reflective wave amplitude to the incident wave amplitude. Point number 4 is standing wave ratio. A measure of impedance matching of load to the transmission line. It indicates the efficiency of power transmission with as SWO of 1 to 1 representing perfect matching. The last one is propagation constant. Describe the effect of a transmission line on amplitude and phase of signal as it is propagated. So next we talk about the type of transmission line. So there are several types in here. One is coaxial. Coaxial consists of inner conductor surrounding by tubular insulating layer, shielded by an outer conductor, braid or foil, and convert with cover with a protective outer check. So it used in cable television, internet connection, and the RF transmission system. And next is twist pair cable. It consists of two isolated wires twisted together to reduce electromagnetic interference. And it is commonly used in telephone line, Ethernet cable, and the other data communication network. Next is waveguide. Waveguide hollow metallic tube or dielectric field tube that guide electromagnetic wave, usually at microwave frequency. And it used in radar system, satellite communication, and microwave oven. Next is a microstrip line. It's a type of electrical transmission line which can be fabricated using printed circuit board technology. It consists of conductive strip separate from the ground plane by a dielectric layer, and used in microwave and RF circuit such as antenna and filter. Next is parallel wire lines, also known as twin lead or balance lines, and a type of transmission line used to carry a radio frequency signal from one point to another. They consist of two parallel conductors that are separated by a consistent distance and are held in place by dielectric material, usually plastic. Antenna feed. Parallel wire lines are commonly used to connect antennas such as TV antenna or dipole antenna or receiver or transmitter. Amateur radio. They are popular in amateur ham radio set up for feeding antenna because they are relatively low cost and have low loss compared to coaxial cable. On the TV system, historically 300 ohm twin lead cable were widely used in analog television system to connect the rooftop antenna to the TV set. Next is streamline. Streamline, a type of transmission line where the conductor is sandwiched between two ground planes and is separated by dielectric layer, and used in high frequency circuit, microwave circuit, and PCB design. Planar transmission line. A type of transmission line where the signal and ground conductor are on the same plane, typically used in integrated circuit. And it's used in RF and microwave circuit on semiconductor chip. And the last one is optical fiber. It is composed of core made of glass or plastic fiber surrounded by cladding, protective buffer, and outlet jack. And it's used for high-speed data transmission, internet backbone network, telecommunication, and medical imaging. So normally it have two type of fiber. One is a single mode fiber, and the other one is a multi-mode fiber. And for the single mode fiber, it is for long distance communication, offering high bandwidth and low signal loss. But for multi-mode, it's used for short distance communication, such as within a building or campus, allow multiple mode of light to propagate. So here all the type of transmission line, and this one is you can see the picture. And the next is we talk about transmission line parameter. So here there are four. Transmission lines are characterized by several key parameters that influence their performance. One is resistance. The resistance of conductor per unit length, which cause power loss due to the heating effect of current flow. Conductance. The conductance per unit length, which represent the magnetic field around the conductor and contribute to impedance. Capacitance. The capacitance between the conductor per unit length, which represent the ability to store energy in electric field. And the last one is conductance. The conductance of dielectric material per unit length represent the leak current through the insulation between conductor. So next is transmission line equation. So the behavior of transmission line can be described using telegraph equation, which are different equations derived from the line parameter. So equation one is vortex equation, and second one is current equation. So here I'm not talking deep in the equation. So we go to next. Impedance matching. Impedance matching is critical in transmission line theory to ensure the maximum power transfer and minimum signal reflection when the impedance of the load match the characteristic impedance of the transmission line. All the power is transferred to the load without reflection. If there is a mismatch, part of signal is reflected back toward the source, leading to the power loss and potential interference. Quarter wave transformer technique use match impedance by using transmission line. There is one quarter wave law. The impedance of a transformer is geometric mean of the source and load impedance. So next is standing wave of SWO. When a signal is partially reflected back to the due to the impedance mismatch, the incident and reflection wave interference creating standing waves. The standing wave ratio is a measure of how effective power is transmitted from the source to the load. So is a standing wave ratio equal to 1, perfect mode, no standing wave. But if standing wave ratio is bigger than 1, the imperfect mode indicates some reflection. Okay, so next is loss in transmission line. So he is have several loss. Several type of loss can be occur in transmission line. One is loss on conductor loss, dielectric loss, radiation loss, and coupling loss. So conductor loss due to the resistance of a conductor leading to loss, and dielectric loss caused by the dielectric material between the conductor, and radiation loss due to the signal radiating away from the line, especially in open line like antennas. Coupling loss occurring when energy is coupled to another line or medium unintentionally. So next is for the practical application. Telecommunication transmission lines are used to carry voice, data, and video signal over long distance. Power transmission high voltage power line used to transmit line to deliver electrical power from plant to consumer. And OF and microwave engineering, the transmission line are essential for routing high frequency signal in device like radio, radar, and wireless communication system. So next is transmission line in practice. In the real world application, transmission line must be carefully designed and tested to ensure that they meet the requirement and performance criteria. Engineering must consider the factor like signal frequency. High frequency require more careful design to increase loss and potential for signal degradation. Environment factor, temperature, humidity, and physical stress can be affect the performance of transmission line. Medical choice. The choice of conductor and dielectric material affect the line impedance and loss and overall performance. Okay, come to the conclusion. So transmission lines are the fundamental component in many electrical and communication systems. Understanding their principle, including impedance, wave propagation, and matching, it is crucial for designing systems that effectively transmit signal over various distance and frequency. Whether in telecommunication, power distribution, or engineer transmission line play a vital role in modern technology. The choice of transmission line depends on the specific requirement of application, including frequency, range, distance, environment, and cost. From coaxial cable used in a home network to optical fiber and enabling global uh, internet connection, each type of transmission line play a critical role in modern communication and power system. So that's all for the transmission line. Yeah, thank you.